And so ADTs and pattern matching, you think about them as like primarily functional concepts, but they're everywhere. This is Python. You can use data classes and tagged unions, which is just the nil cons thing there, to basically simulate an ADT. And it's a bit different. Like, you don't have this containment of nil and cons being inside the same structure. You can kind of use them independently. It's a bit up in the air, but everything in Python is a bit like that. So that's one. There's C++, structs and variants. Same thing, you know? Also separate, not contained within one thing. I think that's one important thing about that we care about, that you know, you have a list, and nil and cons are always constructors of a list and never exist, you know, independently. And Java 17 introduced this wonderful thing called a sealed interface, which basically lets you seal an interface and not keep extending it. And this is what a list looks like. You may think it looks ugly, but I think it's pretty beautiful that you can do this in Java. When I last used Java, I don't think you could do this. And this is kind of what we're going for. You know, this is a pretty nice implementation of, I forgot a closing bracket somewhere. Sorry about that. We do close it, yes. It is a closed list. The whole point of sealed interfaces is that you can't extend them. And this, if you like kind of move stuff around, it looks a lot like a normal ADT. That's pretty cool. And so these things exist, and then now you can think about more functional features, more dependently typed features. And a lot of languages have dependent types. Well, we saw Katerina's liquid type stuff, and you know, a lot of languages let you do stuff in not in the way that a pure dependently typed programmer would think about them, but really the intent is the same, to have a more precise specification. And so what we really have is they're able to comprehend, an experienced imperative programmer is able to comprehend complex imperative programming features, but really they're functional programming features. This parameterized type, that's what we want, right? We want to be able to parameterize types. Well, we want to be able to parameterize types over values also, but I think that's less of a jump than you would think. And so this is the hypothesis, which is imperative syntax for an existing dependent type theory can enhance usability for an experienced programmer. And what do I mean by this? What I mean by this is we're not creating something completely new. Like we don't create a whole language, rather just changing how it looks can actually help. I'm not saying that's a solution, that's the full solution, but it's part of the solution. Just how it looks does matter. And a lot of people in PL really don't care about syntax. Everyone outside of PL cares pretty much only about syntax. I asked like 15 of my friends who are software engineers, informally. I was like, what is your favorite programming language? What is your least favorite programming language? And what do you like the most about it? What do you not like the most about it? 95% of the answers I got were about syntax. And so some of them were, I'm not saying that they're all like valuable to language design. Like some of them are just opinions. Someone said, I really love whitespace in Python. Someone said, I really hate whitespace in Python. And you know, that keeps going. But people really do care about syntax, and it does matter. And a lot of people are gonna, you ask someone about Haskell, I don't like how it looks. Ask someone who hasn't, ask a non-PL person about Haskell. That's what you're gonna get. They're not gonna say anything about how it acts. The first thing people see is what they see. And so I have an experiment in mind, which is a primarily syntactic, and I'll tell you what that means, imperative layer that it elaborates into an existing dependently typed language, which, like I said, must be Idris, for unknown reasons. But you could argue, why can't I just theoretically just say, this is what it looks like, and I make up like just a grammar. Well, this allows me to kind of have some proof that what the two things that I'm comparing are actually the same or act the same, and it's more rigorous and it's more fun. But that doesn't mean I want to actually execute these programs, because, and I'll tell you why in a bit, but it's going to be read-only. This entire experiment is read-only, so really you're only looking at the syntax, and the underlying type theory doesn't change. And yeah, this is to be done. This is not done yet, via a principled empirical user study of experienced imperative programmers. Wow. Yeah, so that is the experiment I have in mind, and now I'm going to show you my syntax that I have developed for this purpose. And the reason it is read-only will come up at the end, but remember that it is read-only. Before we get into syntax, let me remind you, you are not the target audience for the syntax. So I am not the target audience for the syntax. Informally, the people that I have asked do support my hypothesis that this syntax is more readable than functional syntax. You will look at it and go, wow, that's disgusting. But please keep an open mind and put on your like Java programmer hat if you've ever had one. So syntax. And also, the important part is not the choice of keywords or like the specifics. Like all of this varies across different languages. You don't want to make it look like one language too much, but you also don't want to make it look like something completely new. So it's kind of like, the goal is to kind of just get it to look like a jumble of existing things. And so I will not take criticism such as you should have used this different keyword instead of this one. That is not a valid criticism of the syntax, because that is your opinion. And we will never come to a conclusion. We'll be here all day for choosing the right keywords. So we're going to start with the really easy stuff where you'll be like, I could have done that. Okay, yes, you could have done this. Types. We do need types. You may have seen how happy I was with the sealed interface stuff in Java. So it looks a bit like that. We use kind of a function or we use like brackets for everything, because people really like brackets. I like curly braces for one, and also just constructors, arguments. We also have implicit arguments, which you'll see in the next slide. And this is something that people are already used to. And okay, anyone have any major issues with how this looks? Good, perfect. Good. So yeah, the top is the syntax, the bottom is it's Idris, or what it gets elaborated to. I keep saying compiled, it's not compiled. It's also not parsed, but there's a bit more. I don't know what's in the middle, but it's transformed magically. That's what it looks like. And then you have functions and pattern matching, which, by the way, switch cases, like I know a lot of imperative programmers don't like them, but they are basically pattern matching and the best way to do so. But we'll see another way to kind of do pattern matching later. But this is what pattern matching looks like. This is an implicit argument. We also, for types, types have a type tie, just because. And yeah, there's not much to say. Just kind of look at it for a second, let it marinate. Cool, that's enough. Block statements. People really don't like the fact that like functional programs are one big term, and this idea of like sequential execution is, I think, key to imperative programming. And you can do it pretty easily. And also variable reassignment. You tell someone a variable is immutable and they get really mad. So you make them think that you're reassigning the same variable. It's just shadowing in Idris, which is pretty reasonable. And we're able to do this whole block statement thing because we just take whatever is in the function after like a branching operation, and we just put it in each branch. So these two lines go here and here. Yeah, this is exactly how I would write a program in Idris. But that's how you do it. The same thing is done for case statements if you have something outside of a case statement. So you can write a lot of things that look very imperative, which is cool. But you may say, there's nothing really cool about this. I could have done this in an hour. It took me a bit more than an hour, but I believe you. But there is a bit more. And all of this stuff is really like the basic stuff. And so the one important thing that a lot of imperative programmers really like is loops. And so we need to give them a way to write loops. And so this is like a general form of a loop. Okay, general form, you have a bunch of arguments. Just take the head and the tail as like an opaque string, and this is what we go to. It's just a function with a recursive helper. Nothing new about this. I'm sure other people have done this before, but the only thing that we do have to do is pass these arguments into this recursive helper. Pass any variables defined in the header. So I lied about it being an opaque block. But see all the variables that are assigned or declared in the header and pass them into this helper function. Cool. Everything up to now was really about functional programming rather than dependent types. And the main dependently typed thing that, the main innovation? No, it's not an innovation. The main feature that allows you to really use dependent types without knowing you're using dependent types is essentially you're able to go from Booleans to propositions pretty easily without knowing you're doing so. Or you do know, but you don't really have to do a lot of work. So a lot of people like to write stuff like this if they care about safety. Not really. They would do a maybe type, but just think about this function where you have a list, and if it's nil, you return 0. Otherwise, you take the head of the list. And so what we do is we translate it into a case statement that splits on it using a decidable equality function. And so you actually have this proof in context of x being equal to nil or x not being equal to nil. And the wonderful thing about Idris is it's going to pick this up from the context and pass it into this head function on its own. And so this just says that this is an implicit argument. And so all you write is head x here, and then it actually fulfills this constraint on its own. This E is just so you have a syntactic differentiation between when you kind of do this thing and when you don't. You do need decidable equality for this, and so that's what it looks like in Idris. And if you're like, oh, that's not so bad, that's pretty bad, I think. And I've been syntax highlighting by hand, and I really didn't want to do that. So just look at the size. You really don't need to read it. And so we came up with an algorithm to just kind of declare, to have that decidable equality for free. And so for every type that you write, it's going to convert it with the decidable equality judgment. Okay, and so putting it all together, this is a program. Stare at it for 5 seconds. Maybe it's a search through a vector, and it does all the things that we put together, and this is what it goes to in Idris. Cool. Syntax isn't everything. Like I said before, you can only have correct programs. Like this works when you have correct programs, but people aren't going to write programs that compile in the first go. So errors, and this is why I said it's read-only, because if you put like a complicated syntax on top of Idris, and then you look at the error message you're going to get, it's going to be even worse than the one you're going to get when you write like pure Idris, read-only. Bunch of other stuff that we care about. If you care about the actual type theory, come talk to me later. A study that we're looking for, a bunch of parameters that we have to discover, that we have to decide. Mainly, what is the target participant, and what does it mean to do a purely syntactic comparison, and does that even help? That's it, because I'm out of time. Thank you.
Thank you. Questions? Yeah, you can come to the microphone.
Okay. Thank you for the great talk. I have a question. Since we are dealing with dependent types, we are going to operate on proofs a lot. And if we want proves to be sound, we can't have unbounded recursion, or, well, terms have to terminate, otherwise you can prove false. And I wonder how this can appeal to an imperative programmer. So because you need a totality checker, right?
Right, right. Well, I think that just comes down to, like, you can also, there's languages, there's dependently typed languages in which you can do unbounded recursion, and then it'll yell at you, obviously, and then you can say, don't yell at me, I'm telling you that this is terminating. And I would hope that the kind of imperative programmer that I think is part of the semantics, where you kind of have to figure out what it looks like under the hood, which is what I said. You know, this isn't just going to work well. That's why this is meant to be as like this is just about the syntax. So I haven't thought about this goes into the semantics part of it, and so it's not part of this work, is what I would say.
Okay, but like, you still need totality checking. Like it still has to happen eventually.
Yeah. And you're not totality checking is not a syntactic feature.
Yeah, I know, but like I wonder how, because we are talking about adoption of dependent types in imperative programming.
Yes,
so I just imagine that an average imperative programmer would not like that.
Maybe not.
Okay.
But yeah, the answer is maybe not, and it's a future problem, future work.
Okay, I take it as an answer.
Yeah.
Thank you very much.
We can talk after.
Yeah.
All right, cool. So thank you for a very entertaining talk. Yeah. So I'm one of these experienced imperative programmers, you would call it.
Welcome.
I'm also a functional programmer, but anyway, I think your audience is in some sense too broad.
Yeah.
Because like this was kind of very Java focused in some sense.
Yeah, that's part of the question that I've been asking myself, which is, you know, is it different for different people that have experience in different languages?
Yes,
and
that's basically what I'm saying.
Yeah. And that's something that depends. Like I think I would have to restrict the study. It depends on who I choose for the study participants, right? That's something I still have to think about, because I mean I've pitched it as something for all imperative programmers, but yes, I have been thinking about this, and the fact that it would kind of impact different experienced, like it would be different depending on what languages people use. So yes.
Cool. I'll catch you after for a couple more questions. Thank you.